Everybody, Alicia Panzarella here, taking a look at the theory behind our Module 1, which is what is STEM? So a little bit about myself, kind of to start out, I am the physics teacher over at Eastern York High School, but when I'm not teaching AP or academic physics, I do love to pretty much do anything that involves physical fitness. So hiking, coaching, traveling that involves hiking. I did join a foster organization over the summertime, so this is little Dexter. He did find his forever home. And I am an avid reader, so if you're curious, my favorite book of 2020 was The Storied Life of A.J. Thackeray. But really why we're here is to answer the question, why STEM? And it's not just because, at least for me, because, oh, I'm physics, so I'm the S part. It's more so because I truly do believe that the siloed approach is outdated. And I want my students, who are seniors, by the way, to be the 21st century problem solvers that our society really needs. And, they're about to embark on the next stage of their journey that's a little bit scary, and they're going to encounter all of these problems that they never thought of before. So I want them to have the skills necessary to tackle them. And I think STEM is going to help them do that. So my operational definition for STEM is that it is an interdisciplinary approach that teaches students how to learn and apply knowledge in order to innovate. So I kind of mismatched all of our different resources in order to make this. So obviously the interdisciplinary approach was something that was talked about a lot. We are getting away from like, hey, you're just learning physics today, and saying, hey, how can we use that in order to, solve these real world problems? But the biggest thing that I liked about our resources from this week was page 34 when she talked about, how to learn. Because it's so much more than just, hey, here are Newton's laws, plug and chug through this and then you get an answer. No, it's, how can we use these different content aspects to build new pathways in the brain, get you to think differently? And that's really the how to learn part. Obviously, we want them to apply, we want them to be in that higher order thinking. And I use the term innovate at the end here because I think it's a good umbrella word to describe creativity, critical thinking, and problem solving. All attributes that are so part of STEM. So incorporating STEM into my classroom, I do so in two ways. One, utilizing the modeling approach, which is fairly specific to physics, but also I cheated just a little bit with this course because I did take the action research first, and my action research was looking at how does the implementation of the engineering design process affect problem solving abilities. So like I said, I do start with the modeling approach first, which is very much so a discovery-based learning where the students are the ones asking the questions, defining the problems, collecting the data, doing the labs, and presenting their findings to form conclusions. And then ultimately within each unit, there are engineering design challenges that apply all of their knowledge. So the one that I wanted to look at more specifically is our unit 4.1, which is looking at, how can you solve mundane problems with physics? And that's really all I gave the students as a guideline. They were the ones to say, okay, well, if you're saying solve some mundane problem, well, I don't like doing laundry, so how can I make that easier? So what they had to do is pretty much utilize the iterative process. And in doing so, we use a lot of the engineering, the mathematics is in there, but shockingly, very little science when I looked at this. And at first I was kind of upset about this, I'm thinking, what did I do wrong? But one of the things that was discussed in our reading is that not every single activity will be all STEM encompassing. So what I more so thought about after my initial shock is that when we do the modeling approach portion of the unit where we're discovering content, that's where the science and mathematics comes out. And then later in the unit, that's where we have that application stage that has more so the engineering and the math within it. So my shock went from here to about here. All right, so ultimately, we want to look at, why is STEM important? And, on a larger scale, it's vital for our society's growth. It's vital for job security. So students on an individual level who are going into this larger scale, they need to be able to function. And how are they going to be able to function in this highly technological world? And that answer is with being STEM literate. And when you're STEM literate, you have the ability to make new connections in the brain that focus on that creativity, innovation, and problem solving. And then ultimately, my goals for this course, one, I do want to figure out how to integrate more throughout the entire unit rather than just having kind of the science and math at the beginning and the engineering at the end, which will lead into developing more integrated curriculum. And then once all that is done, how can I add a more reflective piece into my units more seamlessly? Because I really do think it is important, but I just can't figure out how to fit it in time-wise. All right, thanks for watching.